Well, hello and welcome YouTube. Mr. Robbins back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you here today, as it is every day here in my virtual classroom. Hey, let's step on inside and let's work more with rational expressions and simplifying them. Last time I worked with multiplying and dividing rational expressions, and multiplying will still happen here, and that's actually why we did multiplying first before adding and subtracting rational expressions. Now, you'd think that that would sound easier to do adding and subtracting, but of course, if they're rational, that means they're fractions. And if they're fractions, that means we need to get a common denominator. Now, I'm not going to get too deep into the rules of common denominators. It's almost going to be assumed or implied that you know a little bit about fractions alongside that. I'll give you one small example of one before leading into something else to make sure you understand why I'm going about what I do to get my common denominators here, but the end goal is going to be the same with that. And I wish these problems got to be a little more creative, and you'll kind of see what I mean when I start explaining them, when I wish I got to cancel some things out more. We'll still do things with excluded values and such, restrictions I should say, that's how I call them. And if you don't know what those things are, it'll probably make more sense in the previous video entry in this series on multiplying and dividing rational expressions. Without further ado, guys, I have 10 problems I'm going to do with you, and I'm assuming that you know a little bit about factoring, about fractions, and about excluded values for this to work and to come to fruition the way that I want them to. So to simplify and state the excluded values here, we're going to have to add and or subtract something. Now, our goal is to get a common denominator. So for example, if I had something like, 2/7 plus 3/7, well, these have a common denominator, so you keep the bottom as you add the top. This is 2 plus 3 all over 7, which is 5/7. That's kind of just how adding and subtracting values works, even if you're dividing by 1. You need to get a common denominator and compare them correctly. So as long as we have a common denominator here, then we can add the top. And they don't have parentheses up at the top, and maybe they shouldn't by and large, but it all depends. I just want you to know that this is a quantity, 3x minus 8, and this is a quantity, 8 minus x. Although we're just adding, I want to make sure that you do understand that this is a quantity and this is a quantity. You'll have to know that for number 2. Now for number 1 here, that is 3x minus 8 plus 8 minus x all over 4x. With the common denominator, everything is dividing by 4x, and we can combine it all as one fraction through addition. So now I'll just combine like terms here. 3x minus x is 2x, negative 8 plus 8 is 0. So you're actually left with 2x here over 4x. Now, x divided by x is 1, and 2/4 reduces to 1/2, and that's just our answer there, 1/2. Probably the cleanest answer you'll get, probably the only one without any fractions here. Now, as far as restrictions go, we still need to state some restrictions as far as dividing by 0. Would we ever divide by 0 at some case? Yeah, before these x's canceled, because they didn't really cancel, right? They just became 1. You have to make sure that we say that we shouldn't have ever substituted 0 for x here. Otherwise, you would have gotten 0 here or 0 here. So x can never equal 0. On a graph, I'm not going to say the graph things from before, but on a graph, this would have been a hole, not a vertical asymptote. All right, that's number 1. Number 2, we still once again have a common denominator here, so we'll keep the bottom as we subtract the top. Now, here's where I stated something about the quantifying idea, and if you don't mind, I will go ahead and group these in parentheses to give this the right idea. 5x plus 1 is subtracting 4x minus 7. The quantity, the fraction, if you will, right? The entire thing is being subtracted. I'm not just subtracting 4x. So let me just write it in parentheses first to make sure that you're getting that good idea of, yeah, guys, I'm not just subtracting the 4x here. I am going to distribute that negative into there. Now 5x plus 1 stays as 5x plus 1. There was no need for me to put that in parentheses other than to just really state I'm quantifying that other one. But 5x plus 1 is subtracting 4x, and I should put a plus 7 here. Again, we're subtracting the fraction. The fraction is quantified. This is almost as if a negative 1 is multiplying by this. Make sure that you're just very careful of that with subtraction. All right, now let's combine like terms here. And we'll get 5x minus 4x is 1x, and 1 plus 7 is 8. So I get x plus 8 here. Now, I haven't done anything yet with this x squared minus 64, and maybe I should. Have you noticed that unlike this last one here, I mean, there's nothing I can do with the 4x, but this is 2 terms, and get used to this, x squared minus 64 is not only a quadratic, but it's a factorable quadratic. This is a difference of 2 squares. X squared minus 64 factors into x plus 8 times x minus 8. Yes, it does. Now, as we've simplified by multiplication, division, what have you, we've seen a fraction of something on top and bottom that can reduce, and that's the same case here. X plus 8 over x plus 8 is a common factor on top and bottom, so this reduces to 1 all over x, or 1 over x all of x minus 8, and that is the final reduction there. Now, there are still restrictions to this thing, guys, just like before. I couldn't plug in an 8 or a negative 8 in this case. X couldn't equal positive or negative 8 here. If it's either of those things, you're getting 0 from the original expression. It always asks about the original expression, or at any time that you're dividing by 0, when is it an issue, and it's positive or negative 8. But that's the simplified expression for that. And again, these ones are very nice looking that they reduce here. At some point when we get into non-common denominators, I think that they don't clean up as well as I wish they did. All right, number 3. Once again, we still have a common denominator, only this time let's work on that denominator a little bit more quickly. Let's actually work on it right now. X squared minus 5x plus 4 looks like a factorable quadratic. It's factorable in the way that if I do negative 4 times negative 1, I'll get positive 4, and negative 4 plus negative 1, I'll get negative 5. Hopefully I said positive 4 when I did that. So up here, though, I do have 3x minus 4 adding with 3 minus 2x. And again, I don't know if it's more comfortable for you to wrap that around parentheses or not. Nothing will change here, but it will with subtraction. So just, again, make sure you know that. 3x minus 2x is 1x, and negative 4 plus 3 is negative 1. So I get x minus 1 over x minus 4 times x minus 1. And once again, we're seeing an x minus 1 over x minus 1 here. Well, it's the first time we see x minus 1 over x minus 1, but once again, we see something that can cancel on top and bottom very happily so, and we simplify this to 1 over x minus 4 with restrictions that x cannot equal at any time 4 or 1. X cannot equal, I'll put 1 and 4. So those are my restrictions for that thing. I don't know if I need to write restrictions, but that's really, it's really domain. It says that x can equal anything else. You're allowed to equal anything else for x, but if you're 1 and 4, you're a problem. Okay, this is the last one with a common denominator here. X squared plus 4x minus 12 on both of those. So, let's take care of that. I assume it's something factorable, and if not, then it's not really a fun problem there. X squared plus 4x minus 12 is x plus 6 times x minus 2. Now, on top here, it's very possible that these things could be factorable, but there's really no need. Our first goal is to work on combining like terms and kind of do something from there. It doesn't actually look like it's factorable. But, as far, we're adding first, right? Factoring this thing won't then let us add these two things. We want to first create a single product on top, because if it's not a single product, something that's only factors without any sums or differences between those factors, then you can't cancel anything on top and bottom. So let's first combine like terms and do 2x squared plus 2x squared, 7x plus 6x, and negative 3 plus negative 1, like that. Now we should probably look to see if this quantity here is factorable, because if this one is here, then we can work to say, is there anything that we can cancel on top and bottom? So let's go and check that out. And I haven't done these problems before, so let's see. It looks like it, I was going to say it looks like it's possible. If this was a plus and that was a minus, wait. Well, maybe it's not possible. Okay, now I was thinking maybe it was possible, but maybe it's not. Let's see. 2 and 2. Let's try this. The only possibility is if we have this, a 4. No, I guess it's not factorable there. I was hoping it would be. See that ends up becoming, I'm not going to say the problem with these problems here, but it would be really validating if every time that you did an addition and subtraction problem like this, that you could factor further and let something kind of, go deeper as you work through it, so you can cancel some things. It kind of makes you feel better about the answer that you got, because, I'll sit and get this answer and say, maybe this was factorable, but Mr. Robinson never found it out to check and see what you could do more of. So we're just going to leave it like that. And, the majority of the problems are going to kind of end up like this now. And I'll have you know, I've created problems like this before where I've tried to do this. They're really hard to come up with. If you try and factor something down afterward and do that. Now restrictions, x cannot equal negative 6 or 2 at any time. All right, numbers 5 and 6 down here. This time we don't have common denominators. So we can't just add across the top as if all's good. We have to first come up with a common denominator. Now, in terms of coming up with a common denominator, I want you to equate this to if we use numbers. If I had something like 1/3 plus 5/6, I need to figure out what this is missing that this has. And I know that you're probably thinking, hey, let's multiply by 2. And you're not wrong. You're not wrong at all. It's exactly what you want to do. But when it comes to polynomials, it's less obvious what it is you might need to multiply to make something happen. So you know what I would do in a number sense here is don't think of the 6 as a 6. Think of it as its prime factors, 2 times 3. And I mention that because this is a lot easier for us to say, well, what does this have that this doesn't? See, now you can say, all right, this is missing a 2. So if I multiply that by 2 there, now they'll have the same thing. You know, and I mean, in these numbers, we'll probably leave them factored, but here, of course, we can turn that into a 6, where we get 2/6 plus 5/6, 7/6, and we, keep going like that. But that's going to be kind of the case here. Look at what factors missing in the other thing, if everything, great, and what factors, what factors missing among them. And that's what you want to multiply in to get the common denominator. So on number 5 here, x plus 2 or x minus 6, I can't do anything yet with right now. I can't simplify that down further. But on top here, I'm subtracting. By the way, always see if you can, well, here, I'm not going to see if I can factor anything here yet. But on bottom, let's see what we can factor here. Well, you know what? There's only one reason you might want to see if something can factor on top. If you can cancel it with something on bottom automatically. If you can just divide things out, that would be nice. But x squared minus 2x minus 24. That can be x minus 6 times x plus 4. X minus 6 times x plus 4. Okay, so we have this factorization here. And you can tell that compared to this other fraction, it looks like this guy, if only this thing had a, an x plus 4. If I multiply this by an x plus 4, then they'd have a common denominator, right? So I got to multiply top and bottom this by x plus 4. That means leave the bottom factored. Leave it factored. Distribute the top, because we're going to do what we did on number 4, where we're going to combine like terms on the top. We're going to simplify that as much as possible. So I'm going to FOIL these parts on the top here. Bottom will stay factored. And on top here, I'll get x squared plus 2x plus 4x, that's plus 6x, plus 8. And minus, remember, it's minus this whole quantity here, x squared plus 5x plus 14. And this is all divided by that common factor, common denominator of x plus 4 times x minus 6. Okay? So I FOILed this thing out, so now I can combine like terms after I, distribute the negative here, where we get x squared plus 6x plus 8 minus x squared minus 5x minus 14. I think next time I won't wrap around parentheses, and you'll just have to know that the subtraction will mean change the signs. Okay, I can still draw the thing from the original problem. I'll probably go about it like this, or I might just say it out loud, so you're just understanding that we still subtract the grouping. So over x plus 4 times x minus 6 there. X squared minus x squared is 0. Those are gone. 6x minus 5x is x, and 8 minus 14 is negative 6. Okay, we get x minus 6 over x plus 4 times x minus 6. And the x minus 6's cancel out. The more that I'm seeing this problem do this, the more I'm thinking that I selected these problems for a reason and thinking they would do this. And the more I want to look back at number 4. Number 4, the top isn't factorable in number 4. I'm questioning if I didn't combine like terms correctly, or if when I typed out this problem from the problem set I got it from, that maybe I didn't type out the right problem thing, because I really would have liked this thing to factor. This thing would have been a really nice, fun thing to factor. I don't know. I'm really starting to think that something else should have happened here. So I'm guessing there's something up here that I didn't type correctly, or I just typed off an incorrect problem or something like that. I'm really not sure, because all these other ones are doing what I kind of want them to do to start with. And like I said, eventually they won't get into this great glory, because the top just won't be a nice factorable set. Anyway, 1 over x plus 4 is the final reduction of that one there. And x could never equal, in this case here, you're looking at negative 4 and 6. Negative 4 and 6, again, division by 0. big no-no, big hassle there. All right, number 6. Once again, we want to seek a common denominator, so I'll just kind of leave the top as what they're doing here. And on the bottom, it looks like this can factor into an x plus 2 times x plus 1. You're lucky we got a lot of 1x squareds. I think I threw in a problem or two that at least has a 2x squared or something somewhere. Up here I have an x plus 3 over, here's a difference of 2 squares, x plus 2 times x minus 2. Okay, we need to get a common denominator, and we're going back to the talk of, what's missing in the other fraction. So they both share an x plus 2 factor, which means I don't need to multiply by another x plus 2 in both of these. Right, it's like if I did something like 1/6 plus 1/4. These guys both share a factor of 2, right? 6 is 2 times 3, 4 is 2 times 2. Why would I multiply this whole thing by 4 over 4 and 6 over 6 when I could have multiplied by 2 over 2 and 3 over 3? Just because I just got to multiply what's missing, right? This is missing another 2 over 2. This is missing a 3 over 3. Multiply by as little as possible. That's going to help yourself, especially with polynomials. And that's why we factor first. We want to see what's the same. So 2 over 2, x plus 2 and x plus 2 are the same. This has an x plus 1 where this doesn't. So I'm going to multiply this top and bottom by x plus 1. And this has an x minus 2 where this doesn't. So I'm going to multiply top and bottom here by x minus 2. Okay. So that's how that thing's going to pan out here. And so I have to do, FOIL distribution up top here and up top here. Then we'll add the results with these 3 on the bottom. All right, those 3 will remain on the bottom there. So FOIL this out. I'll get x squared minus 4x minus 2x, that's minus 6x, plus 8. X squared minus 6x plus 8. And then we're going to add this whole set. X squared plus 1x plus 3x, that's plus 4x, plus 3. X squared plus 4x plus 3. And this is all divided by x minus 2 times x plus 2 times x plus 1. So let's combine like terms, and then we'll see where we are from there. X squared plus x squared is 2x squared. Negative 6x plus 4x is 2x. And 8 plus 3 is 11. And this is divided by x minus 2, x plus 2, and x plus 1. So much like number 4, and I trust this. I trust the math on 4. I just don't know if I wrote the problem correctly. But, you're going to see a lot more of this here, where it would be so cool if somehow this top could factor in a way that's like 2x plus 11 times x plus 1, and then I can cancel out the x plus 1s right there, because it's a little more rewarding that you did all that magic to figure out that it actually cleaned up into something, it made something a little cleaner. But those problems are really hard to make, and this will not be one of them right here. If you could factor this thing further and you could find something to cancel on top and bottom, guys, you would continue. That's one of the reasons we're simplifying the top in that way. Outside of that, it's obviously cleaner than that right there. So restrictions here: x could never equal to -2 or -1. Even though I wrote it out of order, x could not equal to -2 or -1. Those are my restrictions on number 6. All right, 4 more problems to do as far as factoring goes. Okay, so this one has a little more of the deeper factorization when it comes to, all right, I got a 2x squared and 6x squared, no common factors within. So we're going to have to dig a little deeper and make sure we know how to factor those. So number 7 here, I have 3 over, and we'll see what this has to factor to. And, we always hope that they do factor, otherwise it's kind of no good. And then right here, x plus 9 over, I don't know, we'll figure that one out because it's a 6. All right, we'll do that later. Okay, 2x. Now, positive product, negative sum means minus minus. Because it's an odd number, I can't be choosing 6 and 2 here. I couldn't choose them anyway. It can't have a common factor with this 2, so I couldn't put a 12 or a 4 here either. It's either going to have to be a 3 or a 1. Let me try. If I put the 1 here and the 12 here, that's no good. That's too big. So let's try 3 and 4. That'd be -8 minus 3, which is -11. First try. We're all good. All right, this one here. See, this one is a little tougher to play with because 15 being an odd number and this being having an even odd or odd even, like this, means I can't play with that notion of things. What I can say is 15 having factors of 15 or 3, they can't fit into here. They'll have to fit over here. Let me work with the 6x and x first and see how those go. 15 would be too big for this thing. 3, we can try 3 with it. Hold on, let's try it. Let's play plus minus. 3 and 5, that'd be -18 plus 5. That's no good. I think the 6 is going to be too large for this, so let's try the 3 and the 2. 15 would be too big on the other side for 3, so the only possibility of this is if 15's over here and if 1's over there. No, I'm sorry. Excuse me. I said that way wrong. If the 5 and the 3, if the 5 is over here and the 3 is over here. So plus 5 minus 3, let's try that. Negative 9 plus 10 is 1. Okay, there it is. So I technically only tried 2 things there as I spoke through the others. Okay. All right, so there's the factorization. Now, do these share? These don't. Oh, they do. Okay. So these both share a 2x minus 3. You know, I should have done the strategic thing first and said it's probably one of. I should have done that first, of course, guys. This one has to have a 2x minus 3 for this to be as rewarding as it would be to factor those, right? So both these share a 2x minus 3, but multiply the other by what's missing. So what's the missing factor in this one? This is missing a 3x plus 5. So let's multiply top and bottom by 3x plus 5 to earn ourselves a common denominator, given that we multiply this top and bottom here by the missing x minus 4. Hopefully you know what I'm doing with that when it comes to me referring to common denominator there. Okay, so let's go and multiply out that top there. 3 is going to distribute into 3x and 5, and I'm going to get 9x plus 15. And here we're going to add, this is a foiling thing, x squared plus 5x minus 36. Okay, and this is all divided by 3x plus 5 times 2x minus 3 times x minus 4. And combine like terms. We'll get x squared plus, looks like 14x and minus 21. I wonder if the top's factorable there. I haven't looked at it. No, definitely not. That number's too big for that to offset that. So that would be our final result for that one there. And like I said, don't expect things to kind of cancel out after that. That's the best we can do. All right, as far as what x can't equal here, now you got to be a little more careful. X can't equal 4. With these other ones here, if you set 2x minus 3 equal to 0, you add 3 and divide by 2, x couldn't equal 3 halves. And if 3x plus 5 couldn't equal 0, you subtract 5, you divide by 3. So x couldn't equal negative 5/3 that either. All right, so those are our restrictions for that one there. Let's move on to number 8. I haven't used purple yet. So 3x minus 1 over, let's factor that now. That's an x plus 6 times x plus 4. Plus, haven't seen a minus in a while, 12x over. Oh, 2 is a common factor. Hold on. 2 is a common factor. I got x squared plus 4x minus 12. I think we saw that already. X plus 6 times x minus 2. Maybe we didn't. I don't know. Okay, so now we got to find what's missing in these terms here. So they both share an x plus 6. This has an x plus 4. This does not. And this has an x minus 2 and this doesn't. And this has a 2 and this does not. So we have to do 2 times x minus 2 there. So you have to include everything. Make sure you got a full common denominator. Everything matches up. I'll save the 2 for last. First, let's FOIL this thing out. We'll get 3x squared minus x minus 6x plus 2. What was that? 3x squared minus 7x plus 2, and times the 2 on the outside. And then plus 12x squared plus 48x as we distribute the 12x into those two there. This all divides by all that. All right, so we distribute the 2 now. That's 6x squared minus 14x plus 4 plus 12x squared plus 48x. Looks like those are all even. So there's, you know, this 2 in front. That's nice. This 2 in front at least might cancel out. Okay, let's see. So, not much room. 18x squared negative 14x plus 40 is 34x plus 34x plus 4 Yeah, so common factor of 2 we'll be able to pull out of here. X plus 4, sorry about that. All right, so factor a 2 out. We get 9x squared plus 17x plus 2. Whew, that could have been factorable, I think, if this was a minus 2. I almost want that to be minus 2. I'm not sure if anything would cancel from there. Oh, sorry if you couldn't see that. Over 2 times x minus 2 times x plus 6 times x plus 4. Wow. If that... I want to show you something in a bit. So, okay, so that becomes, finally, 9x squared plus 17x plus 2 all divided by x minus 2 times x plus 6 times x minus 4. Or x plus 4. Now, not that we can just make up and change problems, but let's say that said 9x squared minus 17x minus 2. See, if this problem said this, and I'm trying to do this mentally, so let's see if this would have worked. If it said this here, the top would have been able to factor to 9x plus 1 times x minus 2. Confirm that. Negative 18x plus 1x is negative 17x, right? And then the x minus 2's here would have been able to cancel. And see, it's those kinds of problems that, now I can't just manufacture that, right? That's really hard to get to, but that's the kind of problem that I really like on those. If you could actually combine those things and come up with that, that would be really cool. That's not what we have here, guys. That's not this kind of problem, but I'm just saying if those were like minuses there, and I'm sure there's a way that I could think that through afterward and say, what would this number have to be to kind of make that happen? But it might change really the dynamic of everything, because these numbers came from distributing certain things. That's what makes these really hard to come up with in that way. All right, so that's the final answer there. Restrictions are that x could not equal 2, negative 6, or negative 4. All right, last two here. Now, in the last two problems, we have to come up with a there are three terms. I don't want to call this a fraction really, but there are three fractions, whatever. We have to come up with a common denominator for all three. Now there's the 2 that's kind of hanging out, not doing much of anything. I got x over 3 minus x, and I have minus 3 over x squared minus 9. Now, I should probably already factor from the get-go here, because I just spaced these out for no reason. X squared minus 9 is the difference of two squares, guys. That's x plus 3 times x minus 3. And, in thinking about that, of course, we need all of these to kind of have the x plus 3, x minus 3. Right? I mean, do these have it? Well, I guess this looks like, okay, to you guys, this might look like this is something different than these, saying like, oh, we got to multiply these by 3 minus x. No, if you pay close enough attention, 3 minus x is really just the opposite of x minus 3. I'm not saying you can just turn it around, but if you factor out a negative 1, you can just turn it around. This is something that people have a little bit of trouble with, and that's what gives this problem a little bit of trouble. See, 3 minus x is also the same as negative x plus 3. I hope you agree that just changing the term order and not changing the signs still maintains the same expression, right? But if I factor a negative 1 out of there, or a negative, then an x minus 3 stays inside, which means negative 1 can be considered one of the factors there. So I'm going to turn 3 minus x into the opposite of x minus 3. So now they share x minus 3 together. See, now I don't have to reintroduce a new term. Now you might be thinking, oh great, now this has to multiply by negative 1 over negative 1. You could. I don't want negatives in denominators. Never. No, I'd rather just, dividing by a negative means it's a negative value. This plus can easily just turn into a minus. So just turn that plus into a minus. I know that can be a little more confusing with all the stuff that went on. A lot of people have trouble with fractions and negatives and how they work. And furthermore, what I just did in factoring out that x minus 3. But that's why we're practicing it, of course, right? Now, as we try and come up with common denominators, it looks like we do want the x plus 3, x minus 3. So this x minus 3 can gladly multiply with an x plus 3 on top and bottom. And it looks like the 2 needs to multiply by both. Now, as you guys know, x plus 3 times x minus 3 is x squared minus 9. And I'm writing that on top because I just want to distribute the 2 into that. I hope you're okay with me writing that. And on bottom, I'm writing x plus 3 times x minus 3 because we're just going to have a common denominator that's factored here. But the 2 is going to distribute into those two there. The x is going to distribute into these two. And be careful with the minuses here. It's not necessarily an easy problem here. I didn't graduate you guys very slowly for 10 problems, but I wanted to get here. So we get 2x squared minus 18. Now minus. Now I'm going to put this in parentheses first before I do anything else. So x squared plus 3x. And then minus. Oh, the 3 didn't distribute into anything, so just minus 3. Okay, so are we understanding that this will distribute into the x squared and the 3x and turn those negative? Minus x squared minus 3x. That sound good? Okay, this is all divided by x plus 3 times x minus 3. Okay, so now we get to combine like terms here, and we'll see what we got. 2x squared minus x squared is 1x squared. And we got a negative 3x there. And then negative 18 minus 3 is negative 21. That's actually factorable. But, oh, does it cancel anything out? It doesn't cancel anything out. No, that's not factorable. Never mind. I was thinking of 7 and negative 4, or negative 7 and 4, but suddenly that's not 21. Okay, if this was a 4, guys, this is me talking again like the way I did before. If this was a 4, that would totally cancel it. Then this would have been x minus 7 times x plus 3. And that would cancel out the x plus 3's there. Again, that's a hypothetical that's not there. Those are the problems that I like to put into play. But see, we would have had to change everything. You know, this could turn into a 4. Oh, but then that's from this being you know, it's not that simple. It's not that simple to make them. All right, so that's the final result. That's too bad. It's not factorable. They can't cancel. Okay, x cannot equal positive or negative 3. X cannot equal positive or negative 3. Okay, guys, one more problem to do. I'm going to move myself over. One more here. All right, it's three fractions again. Let's factor them bottoms. So we're going to get 2 over, this is x minus 2 times x minus 3. Minus 4 over, this is x minus 3 times x plus 1. And plus 2 over x plus 3 times x plus 1. They give you some pretty easy ones sometimes here. Now see what's missing. Okay, see what's shared, see what's missing. These two have an x plus 1 that's shared. This one doesn't have an x plus 1. So we got to multiply top and bottom here by x plus 1. This has an x minus 3. This has an x minus 3. This doesn't. Got to multiply that by x minus 3. This has an x minus 2. These do not. So these got to multiply by x minus 2. Is that it? Plus 1 minus 2 minus 3. Minus 3 plus 1 minus 2 plus 3 plus 1 minus 3. Oh, there's a plus 3. Oh my goodness. That was the correct factorization, right? Yeah, these are missing an x plus 3, which means this one's missing an x minus... Oh, this one's missing an x minus 2 as well. X minus 2. Hold on. X plus 3 over x plus 3. Whew! And this one, therefore, is missing an x plus 3. Okay. Okay, 4 denominators. Foiling and then times 2. Foiling and then times 4. Foiling and then times 2. So on top here, on top, foil this, we're going to get x squared plus 4x plus 3. Basically, that guy. Over, never mind, not over anything. Minus, I'm just put in parentheses. Oh, hold on a second. This is all times 2. Minus 4 times, now let's go ahead and foil that. X squared minus 2x plus 3x is plus x minus 6. Plus 2 times x minus 3 times x minus 2 is x squared minus 5x plus 6. Just want to make sure I didn't botch anything and all the denominator stuff. Plus 3 minus 3 minus 2 plus 1. Plus 3 minus 3 minus 2 plus 1. Plus 3 minus 3 minus 2 plus 1. Okay, all common denominators. So plus 3 minus 3 minus 2 plus 1. All right. Just keep swimming, swimming. So let's distribute. Boom, boom, boom. We're going to get 2x squared plus 8x plus 6. distribute here. Remember, this is a negative 4, guys. Negative 4x squared minus 4x plus 24, as that's a negative 4. And then this 2 is 2x squared minus 10x plus, that's a 6, so 12. And combine like terms and see if anything's factorable, which again I wish it was. 2x squared minus 4. Oh, 2x squared minus 4x squared plus 2x squared is 0. Those are gone. 8x minus 4x minus 10x is negative 6x. 6 plus 24 is 30. Plus 12 is 42. So there's a bit of something that's gonna, it looks like nothing's gonna cancel on top and bottom. If you ever wanted to play with factoring on the top, because you could, you could factor a negative 6 out of here. So I could just say if I factor a negative 6 out of here, I'm going to have x minus 7. Too bad nothing can cancel. But there we go. I think most of the time they say if it doesn't cancel, you probably leave it like this. But I kind of like the factored one just to say that I practiced it. All right, and that's the last one there. The restrictions are x could not equal negative 3, positive 3, positive 2, or negative 1 right there. Okay, guys, so that ought to do it for this one here. So the adding and subtracting stuff, all about a common denominator. They can get a little complex just because you got to follow a lot of stuff. The things you got to be careful of are things like the subtraction, the idea of the subtraction. But just make sure you're not missing anything, when it comes to that foiling, combining like terms, just knowing your overall objective. And, knowing how to factor in general. So that ought to do it for this one, guys. This is Mr. Robinson. Thank you so much for watching, and I'll see you in the next one. Take care.